Hey, fifth graders, it's Mrs. Seals back for our next science lab. So we are continuing our unit on force and motion. Hopefully you remember a force is a push or a pull that changes the position and motion of an object. We've talked about a force called friction, which is a force that stops or slows moving objects, pushes against the direction of the object. We talked about gravity, which is a force that pulls things together. And on Earth, we observe that as things being pulled towards the center of the Earth. We did the egg drop challenge last week. This week, we're talking about a force called magnetism. So we're going to talk a little bit about magnets. The kids that are in class are going to be doing a mystery science exploration. So they'll be watching a video and getting some time to explore with magnets, and then filling out a recording sheet. That's really all this week is just exploring with magnets and refreshing ourselves, making sure we remember which types of materials are magnetic and which are not. You have learned about magnetism since kindergarten, for sure in kindergarten, first and second grade. No, actually third and fourth also. So yeah, you've been learning about magnetism, but I want to make sure that you remember all those things, like what types of things are magnetic, what types of things can magnets do. So because of copywriting, I will not be able to show the mystery science here since I'm posting this on my YouTube and I did not create that mystery science video and lesson. So I cannot record it and post it here, but I will do my best. We're just going to talk about magnets a little bit, and then I'll show you some things to do to explore magnets. If you have magnets and materials at home, you can also do this. All right. So let's talk about magnetism a little bit. Targets is I can complete a simple investigation that tests the effect of magnetism on an object. So a magnet is an object that attracts or pulls magnetic materials. Magnets can look different. Here are some different types of magnets that you may have seen before. This is a wand magnet. We have a bar magnet and a horseshoe magnet. All of these look different, but they all act in the same way. What materials are magnetic? Certain types of metals are magnetic, but not all metals are magnetic. The most common type of metal that is magnetic is iron. Steel, nickel, and cobalt are also magnetic. So a lot of times people get confused and think that if something is metal, that it is magnetic. That is not true. It has to contain iron, steel, nickel, or cobalt. Here are some objects that are magnetic: paper clips, binder clips, things like nuts and bolts and nails and screws, all are made of steel and contain iron. These things are non-magnetic: plastic, glass, fabric or cloth like our clothes, wood, rubber, and paper. Those objects will not stick to a magnet. We use magnets a lot in our daily lives without even realizing it. A lot of our electronics, like computers, TVs, tablets, our cell phones, headphones, speakers, all of those things contain magnets. If the magnet, is demagnetized or stops working, it can cause the electronic to not function properly. Also, the refrigerator door, the seal, this side has a magnet, this side has a magnet. So when you close the refrigerator door, those magnets are attracted to each other and therefore make sure the refrigerator door stays shut. All right, so just a little bit of exploration today. That's all we're doing. Again, if you have magnets at home, you can do some of these these investigations. One investigation is to show how the magnetic force can actually travel through other objects. So I can show that by, here I have well, let's try it with this one. Here I have a bar magnet, and these are like brads, like little paper fasteners that you would use, in an arts and crafts project or something, and they're magnetic. So it will stick to my magnet, but then I can continue to add more paper fasteners and kind of create like a little chain, because the magnetic force, can you see that? There we go. The magnetic force travels through these objects, through these magnetic objects. Long I can make my chain. You could do this with paper clips. You could do this with anything that's magnetic if you have a magnet at home. So there's 5. Let's see how many I can get. I don't know if I can get 6 on here. I don't think I can. So I got 5. Obviously, if I had a bigger, stronger magnet, I may be able to get more. Something you could investigate at home. If you do any of these investigations, you're welcome to take a picture and email it to me or post it to Schoology. So another investigation or another thing to know is that magnetic force can actually go through non-magnetic objects such as paper. So here I have an index card. I'm going to do the same thing I just did, but now I have a piece of paper between my magnet and my object. So now let's see if that piece of paper there has weakened the magnetic force at all. So remember, before I got 5 paper fasteners here before I lost magnetism. Let's see how many I can get with the paper. There's 3. There's 4. Oh, there's 5. So it's just as strong. Let's see if I can get 6. Nope. So I can still get 5 though. So that means that this little index card didn't really take away any of the magnetic force. I wonder if I had something thicker like cardboard or styrofoam, if that would change my results. Pretty interesting. Something else you can do is I'm going to put some paper clips down here. I'm going to see if I can use my magnet. I'm going to use a wand. Well, that didn't work. Wand magnet to line these up without touching them. Let me use a different one. I wonder if this one will work. Well, okay. I don't think I have the right type of magnet for this. The task was to see if you could put them in a straight line without touching them, but I don't have the right magnet for it. Let's see, what else can we do? Oh, here I have a paper clip tied to a string. Let's see if I can make the paper clip float. Look at it. Oh, this is tricky. Ooh. Look at it. Getting it to float. Let's see if I can get it upside or standing up. Look, oh man, this is fun. That's the thing about magnets. They're really fun, so just explore. Look at that. Oh, I could make the magnet float. Let's try it one more time. It's hard to keep it close enough so that the force is strong enough, but Not too close so that it touches. There we go, there we go, there we go. And it's floating. Do you see that? Can you see that? Floating paper clip. Woohoo! All right, magnets are so fun. Let's see if there's any other investigations for me to do. Oh, here's a fun one. You can, it's kind of like a race. So you can see if you can push one magnet with another magnet without getting them to touch. So you can even do like a race. You can have like a starting line and a finish line and see how fast you can get one magnet to cross without having them touch. There are a couple other little investigations. I don't have the right type of magnets for them now. You need some ring magnets, which I did have. I don't know what happened to them. You can, since you have one side of the ring magnet is the north, one side is the south, you can make them attract and repel and look like they are floating on a pencil or something. um, Lots of fun stuff you can do. So again, today, this week is just all about exploration and investigation, making sure we understand what types of materials are magnetic, what types are not. Hope you had fun. If you do any exploration with magnets, please remember to keep magnets away from electronics because, like I told you before, our laptops, our cell phones, our tablets, um, our TVs, anything like that has magnets inside of them. And if you get a magnet too close to it, it can cause the magnet inside the electronic to be demagnetized, which means its magnetic force doesn't work anymore. And if that happens, it can cause the electronics to keep from working properly. So if you're investigating with magnets, please keep them away from electronics. I don't want any electronics to be ruined. But if you do an investigation with this, take a picture, show me. I'd love to see it on Schoology, or you can email it to me. Um, there's a short quiz in Schoology after this. Remember, it's not required, but I would love to see what you know about magnetic forces. All right, hope you guys had fun, and I will see you after Thanksgiving break. I hope you have a great break. Bye, guys.